here, let's study price elasticity. So here, definition of elasticity. And elasticity measures the responsiveness of one variable, which is usually considered as the independent variable, to change in another variable, which is the consequence, namely the dependent variable. So we use percentage changes to avoid difference in measurement. What does that mean? So let's look at this example. Difference in measurement. So say if we have a capital inflow of 1,000 people, say 1,000 people population increase. If this is 1,000 population increase to Cedar City, which is a very small city, relatively small, or to Salt Lake City, right? It's the same 1,000 capital increase. However, the effect would be different. Say Cedar City has, if Cedar City has 10,000 people, then this 1,000 inflow will cause population to grow by 10%. But say if Salt Lake City has 100,000, right? Then it's only 1%. So here, as you can see, the change in percentage actually reflects more accurately how big the change is to those cities. That's why we're using percentage to avoid difference in measurement in the base population that we are looking into, right? So otherwise, you would say it's the same impact, it's the same 1,000 people increase, but actually the effect would be different, and it's more accurately reflected by the percentage change. That's why we are using percentage change. So here comes the first version of elasticity, which is the percentage change version. So here is the percentage change in quantity over the percentage change in price. How do you understand this? Well, this is to say, hey, if price increase by 5% and the quantity decrease, so this is a demand case, because the law of demand, price and quantity should be negatively related, right? Price increase, then quantity should consumed or demanded should decrease. So quantity decrease by, say, 20%, right? Then what does this quotient tell you? This quotient is actually 20% over 5%. There is a minus sign, right? Because quantity decrease, so it's a minus, but price increase, so that's a positive. So here the result is minus 4, I'm sorry. So what does that tell you? That tells you, okay, per 1% change in price, the quantity demanded in this case is estimated to drop by 4 times of the price change, right? So price, if the price increased by 1%, then quantity decrease should be 4%. All right. So that's why we're using this quotient. This quotient is to say how much your quantity should change. Delta means change per 1% change in price. How much your quantity should change, how much your quantity changes per 1% change in price. So that is what this percentage change is. And here, as the story is told, you should be able to discern one thing, which is which variable is the cause and which variable is the consequence, right? So here we are consumers. We adjust how much we consume according to a change in price. So here the change in price, which is in the bottom, that's the cost. And the quantity consumed, which is the consequence, which is your response to the price change, right? So this quantity is the consequence. And usually we tie consequence to dependent variable and cause to independent variable, right? If I were to remind you, in a linear case, y equals to m plus bx. Here, y, which is standing alone on the left-hand side of the equation, it is the dependent variable, and x, which is mixed together with other constants, that is the independent variable. And if I were to have q being the consequence and p being the cause, then that indicates that the demand function should be written like this. A is a demand, so it's a negative, A minus BP. Okay, so this is how to find out the consistency between the location and how the function should be formed. All right, so the last question, the third question to follow is the magnitude of elasticity. So for elasticity, when you are to report the elasticity, like in this case, you should report the elasticity as -4. Okay, but when you are actually interpreting it, right, which is to say categorize a consumer as an elastic or inelastic or unitary elastic consumer, well, you need to look at the magnitude by looking at its absolute value. So in the case that we discussed above, absolute value is 4. That tells you as your price increase, as your price change by 1%, your quantity will change by 4 times of that 1%. So the quantity change will be of a greater magnitude than the price change. In that case, this consumer is elastic. Okay, so as we are categorizing this consumer into elastic, inelastic, or not, we get rid of the negative sign. We are only looking into the absolute value, but as you're reporting the elasticity itself, you should include the sign. Because the sign has its meaning. The sign here actually tells you the direction, whether the direction of quantity change and price change are consistent or not. If they are not consistent, then this is an elasticity of demand, because the law of demand, because according to law of demand, quantity change should be in the opposite direction to price change, which is consistent with the negative sign. So the negative has its meaning, and we should not omit it when you're reporting the elasticity, but when you're actually categorizing this consumer into elastic or not, you should be only looking into the absolute value. So now, how do we make sense of elastic, inelastic, and unitary? Unitary is like the watershed to separate these two. So for unitary elasticity just equal to 1. Okay. So we were talking about the previous case. But for inelastic, the absolute value of elasticity should be smaller than 1. Okay, so elastic, what does this mean? Elastic actually is also interpreted as sensitivity. And here it's sensitive to price, right? So in this case, price change by 1%, price increase by 1%, right? Quantity will decrease by 4%. So the quantity change is of a much greater magnitude than the price change. That means the consumers are very sensitive to the price, right? When the price only changed by a little bit, you are going to change your quantity by a lot. You're making a big fuss. right? In that case, this consumer is elastic, namely sensitive to the price change. What would be the case? That could be that this consumer has a lot of alternative to go to, right? Say if it is the price of this pen increase, right? But I can go to pencils. I can have millions of other alternatives. I can just not using pen, just using Word document to substitute this. If we have a lot of alternatives, then possibly when the price of this pen increases, then I'm very sensitive. I will cut short my consumption of this pen instantly and significantly. But the other side, the opposite side, is inelastic. If consumers are inelastic, that means consumers are loyal or dependent to a product. For instance, for an inelastic case, say elasticity equals to 0.02. What does that mean? That means if price change increased by 1%, the quantity demanded will only be decreased by 0.02%. That's very minimal quantity reduction. Why is that? There are multiple reasons. Why is possibly consumers are very loyal to these products, right? There is a very high level of consumer stickiness to it. No matter how you change your price, right? Apple being an example, you're loyal to Apple products, you're used to the way that Apple products works, then Apple is able to price high by $200 without undergoing a lot of quantity reduction. That's one thing. Or it could be your daily essentials, right? Even if they increase the price of gas by a lot, especially during winter time because of the need of heating, right? Then we can't decrease our quantity demanded by a lot because we don't have a lot of alternative to go to. In that case, we are loyal to it, we're inelastic to the product, okay? Because we have to. So inelastic is tied to loyalty, dependence, have to. Elastic is tied to sensitive, in which you have a lot of alternative to go to. All right, so now we turn to the last question, which is applicable example here on your slides. Elasticity. Question 1. So if the elasticity of demand for peanuts, right here, if the elasticity of demand for peanut with respect to its price is minus 0.3, if we expect the price of peanut butter to decline by 15%, what is the expected percentage change in the quantity demanded for peanut butter? Show your calculation. Okay, so now let's turn to the calculation. First thing that I would suggest you to do when you are reading those questions is write down the language, translate this language into mathematical expression. So here, the first one, elasticity of peanuts to its price is minus 0.3. And if we expected the price of peanut butter to decline by 15%, so it's a decline, so there's a minus sign, okay? That's a percentage change in price is minus 15. So what is the percentage change in the quantity demanded? Well, so here reading this question, we are only provided elasticity and the percentage change version. So we are going to be using the percentage change version of the elasticity formula, which is percentage change in quantity over percentage change in price is elasticity. And here, what we need to do is just to work out how to find the percentage change of delta Q, which that was the numerator. So here we keep this numerator. And what we do is we multiply the bottom to both sides of the equation. So we have E multiplied by percentage change in P. Just in case you get confused, you can put a parenthesis around the percentage change in P to tell yourself the entire thing is only one term. Okay, so now the last step is to take in those numbers. So we have elasticity is minus 0.3, percentage change in P is minus 15. So the result is 4.5% being the expected increase, the expected change in quantity. So here the answer is, with this given elasticity in this consumer for peanut butter, which is minus 0.3, under a price decrease by 15%, the quantity is expected to increase by 4.5%. And we can check here, at least check the sign, right? Here it is a demand that you're talking about. And to consumers, when things are getting cheaper, you're going to consume more. So a positive 0.5 is reasonable. A positive sign here is reasonable.